All right, there we go. Should be recording now. And yeah, let's get started. So I hope everyone's here because today I'll be taking attendance and all of the TAs will be taking attendance this week. And all right, so let's get started. Okay, so welcome to the fifth recitation of the semester for this class. And today we have some super exciting stuff. We got code review, and we'll go over coding practices because the professor looked at a few of the assignments and he decided that the TA should discuss coding practices with students because a lot of times assignments do get the full score, but it's possible that the assignment isn't that the code quality isn't up to par. And yeah, so we'll have a discussion about PA1 after you guys talk about it in your breakout rooms. And then we'll go over some submission issues that you guys should look out for next time you submit, because there were a few issues and um, I think it's important to cover them. So I have the attendance form here. So um, basically each program in the last assignment was worth 22 points. And so there were 5 programs, so that comes out to a total of 110 points. And as you probably saw, that the assignment is out of 120, so the last 10 points, you're gonna get them from coming to recitation today. And so I'm gonna send out this form in the chat. Oh, thanks, Kevin. Um, yeah, so uh, Kevin sent out the link to the Google form in the chat, so you guys could just click that, and once you get there, you'll just have to enter your name and net ID, and you guys could, and you'll be marked present. I'm pretty sure it's right. I could just paste it in to ensure that it's right. Yeah, that was pretty quick. All right, cool. So yeah, everyone just take a minute or like a few seconds to do that. And so now the first thing that we'll do is code review. So I'm basically gonna be putting you guys into breakout rooms, and let's see how many people are here today. So there's 48 people. So I'm gonna be, I guess, we could do like about 5 people per breakout room. And yeah, so I'll just split you up into 10 rooms. And yeah, so once you're there, you guys should just share your PA1 code, and so you guys could share your screen and talk about it. And then, so basically in this class, every assignment is individual based. And so you guys never really get to interact with each other or look at other code and how other people are doing things. So this will give you a chance to do that. And you'll also get to, yeah, things that you should discuss are your implementation for your programs and some difficulties you may have faced. And you guys could talk about like which program was the most difficult, why, which did you find the simplest. And so so it is code review, so you guys should offer feedback on each other's code. So when someone's presenting, you guys could um, I'll offer some sort of feedback. And so you could talk about the code quality and organization, and if it was easy or hard to read. And you guys could uh, just talk about the ways to possibly arrange the code better, and what you liked about the other implementation, what you thought could have been changed or improved. And yeah, so just you could also just take this time to talk to each other about the course itself, and and just and also just think about things that you think could be improved. And I'd like to hear from you guys afterwards, what your group came up with, what you decided could be improved about how PA1 was structured and all of those things, and if anything could be explained better. And yeah, so I guess I'll be putting you guys into breakout rooms now. And let me see how to do that. Okay, yeah, so it'll be 4 to 5 participants per room, and it'll just automatically assign you. And I'll just pop into the breakout rooms and see what you guys are talking about. And I guess you could take 20 minutes to do this, and then we'll go over the rest of the stuff. So yeah. Okay, I sent you guys the invites to join your breakout rooms, so you should go now. Okay. I'll just give it a minute to let everyone trickle back in. All right, yeah, so I think everyone's back now. So let me pull the chat back up. Oh, oh yeah, sorry about that. Yeah, I just thought that most people were done when I was going into the breakout rooms at the end, so I decided to end it now. And then we could all just like talk about what we thought. So, um, yeah, so do you guys like the idea of code review, and what do you think about it? Was it helpful? Did you like getting a chance to talk to your classmates?
Yeah, it was definitely pretty helpful. Yeah, I
All
don't
right.
think I've talked to like anybody from this class all semester, so that was kind of nice.
Yeah, exactly. So, yeah, I'm glad the professor thought of doing this.
It is interesting to see that most people, I don't know about most, but a lot of people had the same hurdles, same trouble with code.
Oh, really? Yeah.
Memory allocation. I tried to, as I mentioned in the breakout room, I tried to first code in Java and then code in C, just to, compare and contrast, just to learn what the difference is. And what a huge difference. In Java, you just declare and instantiate and go, and does not work like this here. So
Mhm.
a good lesson.
Yeah, exactly. Yeah, C is a lot more, you have to be more careful with the things you do.
Yeah,
Java
high
takes care
maintenance.
of a lot of stuff.
Yeah.
Mm. Okay, yeah, so we'll have more code review sessions, and so I see Kevin said that he thinks that we should have spent more time talking about what went wrong. So I guess you guys could do that next time more. And so yeah, so I guess you guys got the experience, and you guys could could apply the things you learn next time that we all meet up like this. Yeah, that's definitely a good idea. Um, I'll add that to the things that we could improve about it. Yeah. Okay, so you guys probably noticed a bunch of different types of coding styles. And so something that the professor wanted us to go over was code style. So in this class, the auto grader isn't built to check for code quality. It doesn't check if you have all your braces lined up, if everything is indented correctly. But it's still very important to write good quality code because um, you and other people will have to read and understand your code in the future, maybe even now in different classes. And even when I have to grade some submissions manually, it's a lot easier when the code is well written. And so if it's apparent what your code is doing, that just makes it a lot easier. So just think about looking at some of your own old code that wasn't commented, or just everything was in one big main method. And it must have been it's a lot harder to understand what you yourself did. So it's even harder for other people to understand what you tried to do with your code there. So I just wanted to ask, what do you guys think is important for keeping code clean? What are some characteristics of clean code? Right, comments definitely.
I think indenting properly.
Yeah, white space and indenting properly. Just like visually, it should be clear which code is part of which block, which makes things a lot easier. Good variable names for sure. Yeah.
Yeah, I think
Yeah.
you kind of just said that, but also kind of like spacing out different parts of your algorithm so it's easier to read.
Exactly. And yeah, lots of functions. So basically, it's not a good idea to have everything in a big main method. And yeah, you should definitely spread the code out and have functions for things. And each function should just do a single thing, and it makes your code a lot easier to look at. Yeah, avoid redundancy. That's another reason to use different functions, because sometimes you have to do the same stuff over again. Separate header files are definitely useful if you have your code. That allows you to separate more distinct parts of your code. Yeah, not having too many less nested loops, that could be hard to read. Yeah, exactly. So um, a lot of the submissions worked for sure, got 110, but some of them weren't structurally structurally sound. So that's what we'll be going over. So yeah, a lot of this stuff you guys covered. So what makes code clean? Indented blocks, tabs, and lined up braces. White space. So related lines should appear vertically dense. Someone said that spreading out different parts of your algorithms. So um, parts of code that's more related should be together, and then a separate line and then the rest of it, even within the same method. And that makes things easier to look at. And so comments just allow you to justify what you're doing. They're not there to, like, if you're writing an if statement that says, if node does not equal null, you don't have to say checks if node is not null. You should explain why you are checking that. And and you don't have to overdo it either. Like, not every line needs to be commented. And descriptive variable and function names are very important. And small functions that do one thing. And you should just keep it simple. Don't repeat yourself. And you should favor readability over conciseness most of the time. And you just need a good combination of these things. And I have a link to a guide here that lists out a bunch of different stuff that you could use to make your code cleaner. We don't have to implement all of that in this class, but I suggest you guys at least look at this stuff and take care of that. Yeah, exactly. Yeah, helper methods are very useful. Yeah, it makes it a lot easier to manage. And so now we'll be taking a look at, yeah, that link, I'll send it, yeah. Oh, wait, I could just copy it from here. Here you go. And so now I'll just pull up some examples of code from PA1, where all of these pieces of code received very high scores, but I just wanted to take a look at, have you guys see the difference between the different pieces of code? So I'll just share my VS Code screen, and you guys should be able to see it now. And yeah, there's only 10 minutes left, and I didn't realize how long the breakout room stuff would take. So I might not be able to get through everything that I had planned, but I mean, I think I'll be able to get through most of it. Okay, so let me get the chat back. I can't see that anymore. All right, so first I'll show you some examples of code that was well styled. And so here's a function for balanced. And so you could see here in this piece of code that all of these, so first there's the struct and then the methods declared, and there's another method here. And then we have the main method. And the main method uses a clean switch case, which makes things easy to look at. And then we have the rest of the code. And you can see that the main method is pretty small. And all of these methods just do one thing, which is very important. And so this makes the code separated and easy to read. And same thing with this example here. So here, this code actually went even more into the separation using methods. So you could see that the main method is actually really small this time. And everything else is handled by these functions that this person outlined here. So we have the check balanced, compare chars, push, pop, and free list functions. So all of the code was separated into these separate functions. And then even the opening file and the main method was a very small method. And so it's easy to look at and follow as you go through all the different methods to see what's going on. And then we have, I guess we could take a look at this VST reverse order code. So same thing here, short, concise, just like short methods. And then we have the main method, which is also very short because most of the stuff is handled out here using all these separate methods, and things are spaced out well. Indenting is good. Yeah, so all of that's good. Then we have this Goldbach code, which is also um, well structured because it has the separation of methods. And then what else do we have? And then I have this matmul code, which does the same. It's the same concept. It has the separate method. So this method, to read the matrix, you need to read two different matrices. And if you did this in the main, you would have to write two different pieces of the same, like very similar code in order to read the matrices. But this person wrote a method and just they call read matrix on both of them, and that reads both of them very easily, and it's easy to look at. So if you just care about like what the rest of the code does to actually multiply the matrices, you don't have to spend time going through the read matrix code. You know exactly what they did. They read the matrix first, and then they did the rest of the stuff. And this code I have here, this code really separated everything out into functions. And so this is also very easy to look at. And when you read through this main method, you could just see like exactly what this person is doing and exactly what the structure of the code is like. And if there's any method that you want to take a look at specifically, you could go and take a look at it. And then we have this maximum code where there were also many helper methods and a short main method. And then I have some examples of code that could have been styled a bit better. So let's just start off with this balance.c code. And so the thing here is actually this code isn't like it has separation of methods and stuff, but the only thing that I wanted to take a look at in this code specifically was this one return statement here. And it's inside this else block that doesn't have that doesn't use brackets. So, but this return one is indented into it. So when we graded this piece of code, it actually threw an error because the return was indented into the block. And the code thought that the person may have thought that this is part of the else, even if they didn't. And so it threw an error. And so this code initially failed compilation, but then we had to manually go into it. So make sure that if you're using, if you're doing this thing where you don't use brackets because it's a single line, make sure that your indenting is proper. And I just recommend using brackets all the time, honestly. Just makes things easier. You don't have to think about this extra stuff. But if you want to use this method, just make sure that your indenting is proper. And then we have this BST reverse order code. Yeah, so all of this code, all of this this other code ran perfectly and got a 22 out of 22. But so you can see that the indenting and the spacing is very off, and it's a bit hard to look at. So I recommend that you go that you keep it consistent, just like we saw in the other examples. And then I have this Goldbach code. And this is an example of spacing out the code a bit too much. And so not every single line needs to be spaced out. And you should also keep your tabs consistent. And in which case this is a little off here. And yeah, so you should well, yes, the lines are social distancing. Yeah, so you should keep code that that is related, vertically dense, which makes it easier to read, but do space out different parts of your code that do different things. And then we have this matmul code. So basically this is structurally, in terms of tabs and blocks, it's pretty good. But the thing is, it doesn't actually have any other separate methods. So all of the coding is done in this main method. And as you can see, this code is very much the same. And you could write a single function and pass the matrix values into that and free it there. And same thing for setting up and creating the matrices. It's very similar code. So you could just write a function to do that, and you won't have to keep writing more code over and over again. And yeah, so I mean, these two are like the same thing. And then the maximum.c I have here also, it's like the same concept. Everything's in the main method. And although it's not that long, it could help to put it in different functions. And also the indenting could be better. And then this method was left empty, even though the sort array code could have been put into that. So that's basically some examples of code that could be improved, and then examples of good coding style. So make sure you try to follow these guidelines next time. And let me go back to my presentation. Sorry if I'm going a little fast. This is being recorded, so you guys could go back to it. But I just wanted to get through some important stuff. So that's the clean code stuff. And so these are some just tips to be able to do better next time. You could use resources on the internet to help you learn the algorithms, such as for graphs. Ensure your output is formatted correctly, just how the output files dictate. Use a debugger to debug your code. That could be very useful if print statements aren't cutting it. Get started early for sure. And come to office hours and post questions on Piazza. And then, so here are a couple of things to look out for in your submissions. So I have the first thing bolded because I made this list from most common to least common problems. So, but these were all problems that occurred that had to be graded manually. So if if you don't test on iLab, your local machine may not detect memory leaks, and that could cause an issue, and that could result in a lower score than you expected. And we had a few cases like that. And I just want to make sure that everyone knows to test on iLab for sure before you submit your code. And then you have to always you should definitely try to use make to compile your code, because if not, you forget to set important flags that detect memory leaks, so that when you test your code, it actually doesn't even report memory leaks. So and then you realize that, oh, I got 110 out of 110 on iLab, but then it failed when we tested it, and that's because you didn't use make. So if you just used regular GCC without the address sanitizer flag, it won't tell you that you have memory leaks, but we'll use those flags for sure. So it might result in a lower score. And make sure your file structure is correct, based just like the way we provide it. And the instructions will clearly show you how to tar your files and submit it. And make sure the files that you're submitting, you take a look at them before you submit. Like, untar the file, take a look at it, make sure all your code's good, and then submit it. Some people had pieces of code. Sorry, I'm going a little bit over time. It'll just be like a minute. And yeah, so some people had code that wasn't compiling right, but it was compiling for them, and it was because they submitted some file that was like missing a semicolon or a bracket or something like that. So yeah, for the first assignment, we kind of let that go, and I put the semicolon in myself or something like that and tested it. And if it worked, then the person got a full score for that part. But in the future, please make sure that your files compiled correctly and don't have any warnings, because we use the W error flag, which treats warnings as errors and doesn't let your code compile. And then the last thing is just an issue with your tar file. So there were a couple of cases where tar files were submitted, but we weren't able to untar them and there was nothing in them. So a good way to check this is to check the size of your tar file. It should be in a few megabytes, but the files that we got that had issues were only 10 kilobytes. And so those caused errors. And yeah, that's it. So I hope you guys like the structure of code review, and I'll definitely take your input into account and structure it based on what you guys said next time. And yeah, so we'll have another code review set up for the second programming assignment, and I'll see you guys then. And if you don't have any questions, you guys could leave.
Thank you.
Yeah, no problem. If you leave, yeah, if you left a little early, you'd still get the 10 points, so it's fine as long as you attended most of it.
I have a question.
Yeah.
So what exactly needs to be in the tar file for like each program?
In the tar file, so you should tar the folder called PA2, and that folder is going to have the assignment autograder.py, and it's going to have subfolders, which are all the different programs, such as the edge list folder, the find cycle folder, and then each of those folders are going to have the make file, the C file, like edgelist.c or something like that, and it's going to have the autograder.py. And as long as you have those three things and that file structure in each of the folders, it should be fine. So just tar pa2, and then you could submit that.
Okay, thanks.
Yeah. I'm not sure when the second code review will be, but there will definitely be an announcement sent out. So don't worry about missing it or anything. Just as long as you keep up with Canvas, it'll be fine. I'm not sure if we didn't actually go in and look at everything that had so well, we did look at a bunch of the issues, but we may have possibly missed some. So if there was any issue, please reach out by emailing either me or Neeraj, and we'll be able to help you. Yeah, so I'm not sure. We probably got most of the submissions that had issues, but you had a submission, if you think your submission might have had an issue and you got a lower score than you expected, but you didn't get any email reaching out to you, definitely reach out to us and we'll look into it. Yeah, I guess I'll end the recording now so it'll get ready to be processed, and then I'll post it by tonight.
Hi, so I had a question.